Hello friends, welcome to the online platform of Concepts of Geology. We are doing a live session on structural geology practical problems, and these are some recorded versions of classes. Today is the second class of the session, and today we are going to learn about the calculation of attitudes of planes on a flat topography by means of 3-point problem. Now before starting, we need to know what is the meaning of the attitude of a plane and what kind of planes are possible in our structural geology. Attitude of a planar structure means the strike and the dip direction of the planar structure. And what kind of planar structure or planes can be possible in our geology? Planar structure may be a bedding plane, a foliation plane, a plane that is containing a group of lineations, or a plane which is a contact between two rock body. Okay, so these are kinds of different types of planes, and we are going to find out the attitudes of that kind of planes, I mean the strike, dip and dip directions of that kind of planes in a flat topography by means of 3-point problems. Here one thing should be clear, that 3-point problem means we will have data in 3 points, and by using those 3 data we will calculate the attitude of the planar structure. So let's begin. Now before doing the 3-point problem, we will recall the definition of strike line, strike, dip and dip direction. That means the attitude of the plane. The strike line means the intersection line between an inclined plane and a horizontal plane. Now suppose in my field area I have an inclined plane, this one. Okay, this one is an inclined plane, and one horizontal plane, this one. This horizontal plane is intersecting this inclined plane through this line. Okay, so this line will be the strike line of the inclined plane. That means it is the trace of a horizontal plane in the inclined plane. Okay, now suppose my north in this area is like this one. Okay, this is the north direction. Then if it is the north direction, I can measure the orientation of this line with respect to the north. Okay, this line is making an angle, this one, with the north direction. As I have drawn the figure, it seems like that the angle will be 90 degree. So this end of the strike will be 90 degree. Okay, and if this end of the strike line is 90 degree, this end will be 270 degree. That means this is the north, and my inclined plane is striking east west. Now whenever one end of the strike line is having a orientation of 90 degree, other end will have to be the orientation 270 degree, because the difference between the orientation of the two end will be 180 degree. Why? Because strike line is a straight line, and straight line consumes an angle of 180 degree. Okay. Now if you are observing carefully, you will see that I have tried to draw the north arrow in the horizontal plane. Okay, any kind of direction will be measured in a horizontal plane, and in case of here my strike is also will be measured in a horizontal plane. Okay, so the angle which is measured 90 degree and 270 degree with respect to north, all these angles are measured in a horizontal plane. Now remember, whenever you have done field work, you have measured the strike with your clinometer compass or Branton compass, whatever. It is told that make your compass horizontal first. That means we are trying to find out a horizontal plane. So these are horizontal angles. Okay, now what is a dip? Dip means the slope of the inclined plane. Okay, the acute angle between the inclined plane and the horizontal plane measured on a vertical plane perpendicular to the inclined plane. That means suppose this was my strike line, and the inclination of the bed is towards this direction. So I will measure the inclination of this inclined plane through an acute angle on a vertical plane. That means this was the inclined plane, this was the horizontal plane, and this angle will be the dip of the inclined plane. Now very clearly, if I extend the horizontal plane like this one, I will have an obtuse angle, this one also. According to the definition of dip, this angle will be avoided. We will take the acute angle. And on which plane we are measuring this angle? We are measuring this angle on this plane. This plane is a vertical plane. Okay. So dip is a vertical angle. Fine. And this dip is a vector quantity. It has an amount, I mean 20 degree here, and definitely it will have a direction because the bed is, the inclined plane is inclined towards this direction only. Now where this direction we are measuring? Definitely the dip direction will be measured in horizontal plane. So this will be the dip direction, and the dip direction will always be perpendicular to this strike direction. Okay, fine. So if my strike direction was 90 degree here, so the dip direction will be 90 degree plus 90 degree, that means 180 degree. 180 degree means in due south. Now this is again one illustration. Suppose here this is my inclined plane, okay, and the horizontal plane is this one. The north arrow is marked here. Where the north arrow is marked? On the horizontal plane always. Now what will be the strike of this inclined plane? The horizontal plane and the inclined plane is intersecting here. So that means the strike line of the inclined plane will be this one. What will be the orientation of the strike line? This is the north direction, so this will be the orientation of the strike line. Where we are measuring this orientation? On horizontal plane. If this end will have orientation, suppose x degree, then this will have the orientation of x difference 180 degree. Fine. What will be the dip direction? Dip direction will be perpendicular to the strike direction. Okay. The bed is, the plane is dipping towards this direction, so I will ignore this one. So my dip direction is this one clearly. Where I am measuring this dip direction? Again on the horizontal plane. What will be the dip direction? It will be perpendicular to the strike direction. Fine. What will be the value of the dip? The value of the dip will be this angle. That means the angle sustained between the inclined plane and the horizontal plane. And where we are measuring it? We are measuring it on a vertical plane, on this plane. Why? Because this plane is having a strike which is perpendicular to the strike of the inclined plane. Okay, so this is a vertical angle. Now whenever we are measuring the dip, it is told that the dip should be measured on a perpendicular direction of the strike. This kind of dip measurement is called the true dip measurement. Okay, suppose this is the inclined plane, this is the horizontal plane here. So what will be the strike of the inclined plane? Clearly the strike will be this one. Okay, where I should measure the true dip direction? True dip direction should be measured on such a vertical plane which will have a strike line perpendicular to the strike line of the inclined plane. So this is the direction. What kind of direction this is? This is true dip direction. And apart from this true dip direction, any other direction will be apparent dip direction. Apparent dip means this is a dip, this is the slope. This is also measured on a vertical plane, but the vertical plane is not having the strike perpendicular to the strike of the inclined plane. It does not have the perpendicular relationship. It may have, suppose, 30 degree, 20 degree, 60 degree, whatever, but not 90 degree relationship. Suppose I need to measure the apparent dip direction on this plane. So that means this is my vertical plane on this direction, and I will measure this angle as the apparent dip. Okay. So this is the true dip direction and this is the apparent dip direction in case of this figure. Strike line is this one. Now very clearly any kind of dip measurement is in vertical plane and any kind of direction measurement is in horizontal plane. True dip will be always the maximum dip possible in case of a inclined bed. Okay, so this is the true dip direction, and if I am moving in any direction, I will having a lesser value of dip, and eventually if I measure the dip in this direction, I mean parallel to strike direction, the dip will be 0. Okay, parallel to strike direction dip is 0, perpendicular to strike direction, I mean true dip direction, the dip will be maximum, and in between them the dip will have an intermediate value. Okay, we have used it in our practical life. In the hilly terrain, we have made our approach roads in a helical manner. Okay, if I move in this direction directly, I will have a maximum slope angle. That's why I am not moving directly like this one, rather I will move like this one. So I am moving in apparent dip direction to minimize my energy consumption. Okay, now suppose I have a block diagram. This kind of diagram is called block diagram or isometric diagram. Here it is shown that this is suppose an inclined plane. A horizontal plane may be imagined like this one, which is intersecting it in this line. So that means what? This intersection line will be the strike line of this inclined plane. Fine. If my north direction here is this one, this angle is measured as 45 degree, and this angle will be 45 plus 180, that means 225 degree. So this is the strike, or this is the orientation of the inclined plane. On which plane the orientation is measured? Again I am saying this is in a horizontal plane. Which will be the dip direction of this inclined plane? The dip direction will be 90 degree apart. True dip direction, I mean I am talking, it will be 90 degree apart of the strike direction. So it will be 90 plus 45, that means 135 degree. Okay, and here it is written that the value of the dip, I mean the angle of the dip is 50 degree here. Okay, now if this is the strike line, I mean in this level, in this height, I have a horizontal plane which is intersecting through this line. Now suppose in this height I also may have a horizontal plane which will intersect the inclined plane here, and again in this height I may have a horizontal plane which will intersect the inclined plane here. I may have a group of parallel lines, all will be strike lines of the inclined bed, but the level will be different. Exactly the same thing is done in case of this figure. Okay, here you see we have a group of parallel lines, this one, this one, and this one, this one, all they are strike lines, but I have different elevation values. Suppose this is minus 200 meter strike line, this is minus 300 meter. Now why minus? Minus means we are going in depth. Suppose my datum plane is this one. This one is the horizontal plane, and this one is the datum plane. Okay, so if this one is the datum plane, it is a horizontal plane and it is intersecting the inclined plane here, so this is the strike. All parallel lines will be the strike. Suppose if I do a borehole here, I will intersect the inclined bed, suppose here. So that means here I may need the borehole depth, suppose 400 meter. Again I may do a borehole here and I will intersect the inclined plane here. On which depth? Again 400 meter. So if I join these two points with a line, what will be this? The line joining the same point of elevation or depth, this is called a contour line. So that means this is definitely a contour line. Contour line is having which value? Minus 400 value. Why? Because it is in depth with respect to the datum plane. So where I am drawing this contour line? I am drawing this contour line, suppose this is a strata, and I am drawing the contour line on this strata. That's why it is called a stratum contour. Okay, and this is definitely the minus 400 meter strike line for the strata also. So this is minus 400 meter strike line or minus 400 meter stratum contour also. Now I will project it in the horizontal plane. Okay, we are going to make a map. Projection means we are projecting it in horizontal plane, means we are making a map. Now when we are making a map, this point is having a depth of 500 meter. It will be vertically uplifted here and it will be projected on the horizontal plane, on the datum plane, and I can draw a line with the same orientation in this map here. Okay, that means I have also projected this end here. Okay, so now this is the 500 meter strike line and this is in a projected mode. That means it is on the map. So it will be called a map strike line. Okay, because this is a strike line and drawn on a map. Okay, what will be the value of the strike line? Minus 500. It is also called MSL, map strike line. Don't be confused with the mean sea level. This is map strike line, and all the parallel lines will be also map strike lines, but they are having different elevation or different depth value. Okay, all they will be parallel and their spacing is called the contour spacing, or here the strike spacing. Okay, now very clearly, more the deep of the inclined plane will be, this spacing will be lesser. Okay, and if eventually the inclined plane becomes vertical, all the stratum contours is going to be superimposed in one another. Okay, and ultimately they will be one line. That single line will represent the stratum contours of all the different elevations or different depths. Okay, so whenever in a map we are getting that the stratum contour lines are closely spaced, that means the plane, the inclined plane, is very much inclined, and whenever they have a wide spacing, that means the inclination of the inclined plane is lower, it is nearer to horizontal. And when it is truly horizontal, the spacing between the strike line in the plane and in the map will be just same. Okay, because when the plane is horizontal, it is itself representing the map view. Now we will enter into the domain of 3-point problem, which is the topic for today, and we are doing the problem in a flat topography. So suppose this is the topography. Okay, this is exactly horizontal, and this is the inclined plane for which we are going to measure the attitude. Now this inclined plane and the horizontal plane is intersecting by this line. So what is the meaning? This intersection line is the strike line of the inclined plane. Okay, now I will do 3 borehole to encounter this inclined bed or inclined strata from this flat topography. Suppose I have done 3 boreholes on point A, B and C. So the 3 boreholes are encountered this unconformity at, suppose, at 500 meter depth, 2000 meter depth and 1500 meter depth. Okay, clearly as the bed is dipping on, as the unconformity is dipping on this direction, this borehole, the C borehole, has to be drilled up to the maximum depth. Now I have prepared a map view for this area, and on the map view I am having 3 points A, B and C, and the depth value of the borehole done on A, B and C are written here. So these are my 3 data's on 3 points, and with help of these 3 data's we are going to find out the attitude of the unconformity. What we will do first is we will make a triangle by joining the 3 points A, B and C. This one. On which plane I am doing this? Here I am doing this on the map view, and in reality what I am doing, I am joining these 3 points on which plane? On this inclined plane, on this unconformity. Okay, so suppose at this point A I have encountered the unconformity in 500 meter depth, and at this point at C I have encountered the same unconformity at 2000 meter depth. That means if I do boreholes here, 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 okay, I will have intermediate values of depth where I will encounter the unconformity. Suppose this is 500 meter depth, then suppose this is 1000 meter depth, or this is suppose 1500 meter depth, and gradually we will come to a point where I will encounter the unconformity at 2000 meter depth. So I will do the same thing with this map view also. When I have depth value 500 meter here and 2000 meter here, so that means if I make 500 meter graduation in this line, I will have 1500 meter value here and 1000 meter value here. This is 500 meter graduation, this is 500 meter graduation. Okay, how to do that? Suppose the distance between A and C in the horizontal plane is 10 centimeter, and I need 3 divisions on this line. Okay, so each division will be 3.3 centimeter in length. I will measure 3.3 centimeter here, here and here, and each of these divisions will have a vertical fall of 500 meter. So now I have got the 1500 meter depth value here. So that means if I do a borehole from here, I will have a depth of the borehole 1500 meter, and the borehole will intersect the unconformity. Now remember, I have already done a borehole, this one B, which has encountered the unconformity at 1500 meter depth. So that means if I join these 2 points 1500 meter and 1500 meter in map view, I will get a strike line. Okay, this will be a contour line also. What I am actually doing, I am joining this point and this point by a line. So that means this is a contour line. Where I am drawing the contour line? Here I am drawing the contour line on the inclined plane, so that means on the unconformity, so that means this is a stratum contour, and here I am drawing the strike line on the map, so that means it is a map strike line. What will be the value of the map strike line? It is minus 1500. Why minus? Because remember, this was my datum plane, the horizontal plane, and I am moving in depth. So in depth means it will be negative value. So this map strike line will have a 1500 meter value but in negative. Now similarly, I can draw a strike line which will be parallel to this strike line and will go through this 1000 meter point. So this will be how much strike line? This will be minus 1000 meter strike line. Similarly, this will be minus 500 meter. So this is the procedure to draw the strike lines in a map. Okay. What I have actually done is, in the inclined plane, I have drawn this strike line and this strike line and this strike line, and I have projected this strike line on this horizontal plane, and I am getting this view actually. Okay, this is the map view. Now to find out the intermediate value, that means 1500 meter strike line, in case of this example, I may have a geometric method also. Okay, for doing that I need to draw a horizontal line, okay, this one, which will be equal to the AC line. Okay, so that means in this end, on this point A, I have a borehole of 500 meter depth, and here on the C point I have the borehole of 2000 meter depth, which are encountering the unconformity plane. Now I will take the map scale. Suppose my map scale is 1 centimeter equal to 500 meter, and I will draw the boreholes on point A and point C. So on point A, this will be a 1 centimeter line because the borehole depth was 500 meter and my map scale is 1 centimeter equal to 500 meter. And on point C, I will have a 2000 meter borehole. This will be 4 centimeter according to my map scale. Okay, so both these boreholes have encountered the unconformity on here and here. Okay, these points. So if I join these 2 points with a line, I will have the appearance of the unconformity along this AC line. Okay, actually we are making a vertical profile along the AC line. Okay, and on this vertical profile the appearance of the unconformity will be like this. Okay, so don't try to measure this angle as the dip angle. This will definitely a dip angle, but this will be an apparent dip in this AC direction. Okay, we have to measure the true dip direction, that means perpendicular to the strike. Okay, Now if this is 500-meter borehole and if this is 2000-meter borehole, then definitely in between the A point and C point I will have a borehole length which will be 1500 meter. Okay. To find out the position of this borehole, I need to draw first 1500 meter horizontal line. Okay, I will convert it in my map scale. So 1500 meter means 3 centimeter in my map scale. I have drawn a 3 centimeter line. After that, I will need my divider to copy this line. We all have seen this instrument in geometry box, but I don't know what is the use of it. The use of the divider is to copy a given line. Okay. So I have drawn a 3 centimeter line and this distance will be copied by this divider. Okay, and after that I will place the divider in this triangle and I will try to find out by hit and trial method that where the 3 centimeter length is fitting on this triangle. Okay, so suppose this is the position where the 3 centimeter line is exactly fitted. Okay, so then I will measure this length. Okay, from this A point. Remember, I am measuring this from this A point. Okay, this is very important. I will measure this line and rather I will copy this length. Okay, so now I have got the 1500 meter strike line. This is negative value. Now which will be the dip direction? The dip direction will always be perpendicular to the strike direction. I am talking about the true dip. So the dip direction will be either in this direction or in this direction. Now from this inclined plane, from this isometric diagram, we are seeing that the dip direction is always towards in this direction. That means from A to C. So here the dip direction will not be this one. The dip direction will be this one, from A to C. But it has an orientation perpendicular to the strike. So the dip direction will be this one. Now remember it as a thumb rule that an inclined bed always dips towards the lower value contour from the higher value contour. Don't be confused, this is negative value. So that means minus 500 is a higher value than minus 2000. In case of topography also, you may recall the slope of a hill is from the higher contour value towards the lower contour value. Okay. So now we have got the strike and the dip direction of the bed of the unconformity. To measure the amount of dip, we need to find out the spacing between two map strike lines. So actually what I am doing, I am projecting this point on this map view and this point on this map view, and I am measuring the distance between them. Okay. Here I had a depth of 500 meter and here I have a depth of 1000 meter. That means the vertical fall is 500 meter. Okay. Now see again through this illustration. I have drawn the 500 meter strike line here and 1500 meter strike line here. The vertical gap between them, the vertical spacing between them is 2 centimeter. On which plane? On the map view, on the horizontal plane. Okay. This is measured perpendicularly to the strikes. That means I am taking it in a true dip direction. I have drawn the 2 centimeter line here. The vertical fall between them is 1000 meter. So this is the 1000 meter vertical fall, suppose according to my scale. And I am joining this point and this point through a line. This is the appearance of the unconformity in a vertical plane, and this angle will be the true dip angle. Okay. The dip direction is from minus 500 to minus 1500. All the values in the triangles are written in negative. So this is the procedure to solve the 3-point problems. So first we have to locate the 3 points on the map A, B and C. Then I have to construct the triangle. Now I have to find out the side of the triangle which is having the minimum depth and maximum depth, or minimum elevation and maximum elevation. I have to graduate this side. Okay, and I have to make the graduation in such a manner that I can get the other point value on this line. Then I will join this same value with a line. This line will be map strike line. Fine. After having one map strike line, we can draw the other map strike line also. All the strike lines will be parallel. I have to find out the dip direction. This will be perpendicular to the strike lines, and the direction will be towards the higher contour to the lower contour. Take care of negative positive values, otherwise you will get a dip direction inverted. Then to measure the angle of dip, find out the contour spacing on the map view, draw a triangle, put this horizontal spacing on a horizontal line and the vertical fall of the contours in a vertical line. Convert the vertical fall of contours suppose in your map scale. I will join these 2 points through a line. This will be the appearance of the bed. I will measure this angle to find out the dip angle. So this is the entire process to solve a 3-point problem, and we are solving it in a flat topography. Whenever we are doing 3-point problems on flat topography, we are taking that topography as the datum plane. So whenever I am doing a borehole from this datum plane, we are definitely going in depth, so all my contour values will be negative. I will give you a problem to solve and you solve it on your own and post it on the comment section, or you may send it in the registered email ID. You can join the live classes also. For any type of queries also you write on the registered email ID. Now this is the problem. 3 boreholes A, B, C are drilled on a flat surface and have encountered a coal seam at 200 meter, 1200 meter and 700 meter depth respectively. The forebearing of A to B is 300 degree, 330 degree. That means suppose this is the north of my map. First mark the north arrow, then write the scale here. The scale is 1:10,000. That means 1 centimeter in the map equal to 100 meter in the ground. Then place the point A anywhere on your paper. Okay. Take 330 degree forebearing. That means this angle will be 330 degree. Draw a line along 330 degree. Now see the distance between A and B is 1000 meter. So according to my map scale, the distance will be 10 centimeter. So suppose this is 10 centimeter. So my position of B is here. So after locating the B, I need to locate the C again. The clue is the back bearing is 15 degree from C to B. Okay. So that means this is the B, and I have taken the back bearing. I am standing on the B and I am taking the back bearing from C, and the back bearing is 15 degree. I don't know where the C is located. Okay. So when I don't know where the position of C is, I can't take the back bearing actually. So here the clue is you need to convert the back bearing into forebearing value, and the hint here is the forebearing and back bearing is having a difference of 180 degree. Okay. So you convert the back bearing value into forebearing and plot it. You will get the C. Suppose I am having the C here. The distance is given, it will be 700 meter, this line will be 700 meter. So this is the C. So I will join ABC points and I will get the triangle. So these are the clues how to solve the problem. So I think you have understood the solution of 3-point problems in a flat topography. For practicing purpose, you should do some more problems by your own. Okay. And if you are having queries till now, you may post it in the comment section, or you may join my live classes. There we will have a doubt clearing session. Okay. Thank you for watching and goodbye for today.